the the surface, let's say surface temperature is Ts and it is constant throughout at every point, and then thermal boundary layer will also form near the surface. That thermal boundary layer can be of same size, different size, depending on the fluid itself. Let's say this is thermal boundary layer. So if we draw the velocity profile and temperature profile at any location x, it will look like this. This is temperature profile I am drawing. Since the higher temperature at the surface, the layer of the fluid which is in contact with the surface will be at the same temperature as the hot surface. This is called no temperature jump boundary condition, and fluid is moving in this direction. And if we draw the velocity boundary layer, velocity profile will look like this. After this point, there will be no disturbance of the fluid. Because of the flow of fluid over the surface and because of the temperature gradients, we can see this is high temperature, this is low temperature. We are not drawing the arrow here because temperature is a scalar quantity, whereas velocity is vector quantity. So this is temperature profile. So this is temperature distribution as a function of y, and this is velocity distribution as a function of u, as a function of y. So because of the heated surface, heat will flow to the fluid and fluid will get hot. So convection, as we studied above also, the convection can be of various types: forced convection, natural convection. This is forced convection. This is natural convection. In forced convection, the fluid is moved over the heated surface by the external force, like fan is used here. Fan is forcing this air to move over these heated printed circuit boards that are used in our laptops. So we use fan in our laptops to cool the PCBs. So that's how it is used. So this is forced convection. Forced convection is efficient mode of heat transfer as compared to other convection heat transfer, like we can see in this B figure that here there is no external force and no external fan is there which are moving the fluid. Here the hots, I explained yesterday also that when a stagnant fluid is coming in contact with a hot fluid or vice versa, the convection current starts. What happens is, when, let's say this is the hot surface, so when this fluid particle come in contact with the hot surface, its temperature rises and its density decreases. This fluid particle's density, so it will become lighter, and this will be the force is acting on it, force mg downward and buoyancy force upward. Its density get lower, so rho times volume into g, and surrounding fluid is still having higher density. because it is not get hot surrounding fluid. So let's say it is rho L surrounding fluid, rho S. So bouncy force on it will be rho S L, rho S volume of the fluid particle that is displaced by it. So since rho is less than rho S, upward buoyancy force will act on it. It means Fb is more than weight, which result in upward net upward force on it. Net upward force, and then this particle goes like this, again get cool, again come down, and when it gets moved to above, void is created, and void is filled by the cold fluid, and again this current keep on moving. Since the fluid is moved only by itself, by the hot surface, there is no external force like fan, pump, so that's it is called natural convection. That is what's shown in the. But in some cases, both force convection and natural convection comes if the fan speed is not too much high, then both natural convection and force convection can occur in the same application. So if we want to see that who is efficient mode of convection heat transfer, we can see this, like if we see the free convection in gases, it has very low heat transfer coefficients, but if liquids are using for free convection, their heat transfer coefficient is quite higher. But if we use forced convection for gases as compared to free convection for gases, forced convection for gases is having higher free convection, higher heat transfer coefficient. It is quite obvious that if we put our hand, if we put our means hot coffee in the room, stagnant room, it will not cool. But if we blow air over the coffee, it will cool soon, right? Because this is the reason, because heat transfer coefficient value is higher for forced convection of gases. So there are other modes of convection heat transfer which are phase change heat transfer processes, like which are shown in here. When we are heating this boiling water, its temperature will rise and convection current will form, natural convection. But that is the sensible energy that is coming. But if with the temperature of the surface is such that it is reaching the saturation temperature of the water inside this pan, then the bubble will start from the surface of the heater plate. It will rise by taking the heat from the heater surface and burst into the liquid, and similar process, and again, and after that so many bubbles start forming one after another and hit the whole pan. This is boiling, and opposite of this is condensation. If the surface, if let's say let's say this is the pipe which is running at minus 15 degree Celsius. Let's say 15 degrees Celsius. Let's say 15 degrees Celsius, and outside is hot air. So what happens, we have seen that outside our water bottles some condensed water has come. This is nothing but the temperature of the surface of the tube is less than the saturation temperature at that particular condition. If this condition is fulfilled, then surrounding fluid will condense. And for this condition, if surface temperature is more than the saturation temperature. So, in nutshell, convection heat transfer is energy transfer due to combined effects of conduction and bulk fluid motion. Conduction, why conduction? Because the very first layer of the fluid which is in contact with the solid surface, it is at rest, and the layer which is at rest, it will transfer heat energy by conduction, and above the stationary layer of the fluid, bulk motion of the fluid is there. That bulk motion of the fluid will take that heat away from the wall and will advect it downstream. So this is the convection heat transfer. So next we will study about the radiation.